Hey guys, we're going to do a video here on something called the stem and leaf plot. And what this basically is it's another way of looking at data. So in this whole playlist of videos that we're making, everything's about going out, collecting a bunch of data, getting some real life numbers. But then after you go and get those numbers, you got to look at them and kind of study them and see what you find. And a stem and leaf is just like one way you can organize that data. It's really visual for people so that you can look at it and feel like you can see what's going on with the data. So for your notes, you might want to write this down. This is kind of my definition. One important thing about a stem and leaf plot is it's just a way to organize data numerically. So it's about putting the numbers in order from least to greatest. That's what that means. And that's really helpful when you want to find the mean and the median and the mode and some of that stuff. So a stem and leaf is just another way of organizing numbers. Another thing I'm going to write down is it shows how the data is distributed. So like I said, it's really visual. You can look at a stem and leaf plot and you can see where the majority of the numbers are, where's the outlier, where's maybe some strange data versus some trends in the data that look pretty normal and obvious. So it's just a way to look at numbers. And I'm actually going to show you what it looks like first, and then we're going to try one together. So here is a stem and leaf plot. Let me show you one. Basically, it looks a little bit like a T-chart. We call the left side the stem and the right side the leaf. And this one happens to be a bunch of data collected on the ages of people at a family reunion. So if you've ever gone to a big family reunion, you know that you have the old grandparents all the way down to the little babies and kids that are cousins, and there's a big age range. Well, that's what this is. The stem and leaf plot is an organization of the ages of people at this reunion. And one thing that's missing is we need a key. So at the bottom, I'm going to write key. And if you want to pause the video and maybe copy the stem and leaf plot down, it might be a good idea. But here's the key for this stem and leaf plot. If I write 3/4, what that represents is the number 34, which is somebody's age in this table. So when I look at this table and I know that 3/4, that means the 3 and the 4 here make the age at 34. What I can tell you is these are all the ages of all the people. So this guy down here is 81 years old. So I'm going to organize these numbers starting at the top. Starting with the 0, we have a 1-year-old, an 8-year-old, and a 9-year-old at this family reunion. So 1, 8, and 9 are their ages. In the 2 category, we have, let's see, 2-2 means we have a 22-year-old. 2-2 means we have another 22-year-old. 2-9 means we have a 29-year-old. Then we go to the 3s. We have a 3-0. That means we have a 30-year-old. We have a 3-4. That's a 34-year-old. We have a 3-6. That's a 36-year-old. And then for the 4, we have a 4-5. So that's a 45-year-old. And we have a 5-1, which is a 51-year-old. A 7-8 is a 78-year-old. And our oldest person is 81. And basically, that's it. That's what the stem and leaf has done. It's taken these ages and organize them in another way that you can see it. But you know how that's helpful? Well, you can really tell that at this family reunion, most people are on what I would say the younger side. They are in their 30s or lower. You can see there's not very many people above the age of 30. We have one 45-year-old, one 51, one 78, one 81. But the majority of people at the reunion are in their 30s or lower. So that's something you can see right away by looking at that stem and leaf. You can also take this data and you can do all the things we've learned in previous videos. You can find those measures of center. You can do our mean, our median, and our mode by looking at this data. In fact, I'm going to do that right now. Let's find our mean, median, and mode. We know mean is the one that takes the most work. It means average. We need to add up all of these ages and divide them. And let's see how many people there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 people. So when we add up our mean, we are going to be dividing by 13. So maybe you should pause the video and add up those numbers and see if we end up getting the same total. But I'm going to try it here. We have a 1-year-old plus an 8-year-old plus a 9-year-old. We have a 22-year-old, another 22-year-old, 29-year-old, add the 30, add the 34, add the 36, add the 45, the 51, the 78, and the 81-year-old, and we have a total of 446. So we have 446, which we're going to divide by 13 now. So divide by 13. And you get a decimal, of course, 34.307 something, something, something. So I'm going to do the wiggly equal sign to show that I am rounding to about 34.3. And that really makes a lot of sense to me, actually. It's saying, like, hey, the average age of a person is 34 years old at this reunion. And if you look at your stem and leaf plot, that kind of makes sense. So this is the average age. Average age of somebody at this family reunion. Median and mode are going to be quicker. Median means middle, so we have to find the number that is in the middle. I like to do it by just kind of eliminating from the lowest and the highest. So 81 and 1, that's the lowest and the highest, and 78 and 8. And I kind of like to just continue this pattern until I get to my center to see what is in the middle. And it looks like 30. 30 is in the middle. So our median age is going to be 30. 30 years old. And the mode means what number do you see the most? And I only saw one repetitive age. Which age was that? Well, there were two, they're right here crossed out now, but there are two 22-year-olds that were at this reunion. They're right here in the stem and leaf, those two people. They're both 22. That's the number that I'm seeing the most of. It's the only repeated age. So the mode is 22. Let's add a fourth thing on here. This was not in the last video that you may have watched, but let's add on the range. The age range is, it means the range means from what's the lowest value to the highest value. What's the difference between those? Remember, our oldest person in the stem and leaf was the 81-year-old. And our youngest person is only 1 year old. We have a little 1-year-old and we have an 81-year-old, probably grandparent. So the range on this is 80. There's an 80-year range. 80-year range. That would be my range. So let's try a problem where we don't start with the stem and leaf, where we actually have to go create the stem and leaf, where we do a little bit more of the work. Let's give one of those a try. And I think for our notes, I'm just going to write example, like that. And let's say you've collected some data. I don't know what it's on, but let's say we have some numbers. So here are our numbers. We're going to write them down. We have 24, 19, 23, 12, 6, 21, and 15. All right. These could be people's ages, or it could be something totally different. I don't know. But let's go with it. Let's create our own stem and leaf for this data. So up above, I'm going to say, here's the data. These are the numbers that have been collected. Now what we're going to do is we are going to create our stem and our leaf. And the easy way to do this is just make it look like a T-chart. So I'm going to take stem and leaf and split it down the middle. I'm also going to need a key down at the bottom so people can understand it. So I'll make sure to include that also, which is way down there. My numbers, it helps me to look at the lowest and the highest numbers first. So like the smallest value I see is 6. And the highest value I think I see is the 24. So we don't have a big range, 6 to 24. So for my stem, I'm going to start with 0. I'm going to go 1 and 2. And that's it. My key is going to say that if I have 2/4, that represents the age or the data point 24. So what will go with the 0? Well, the number 6, because there's no digit in front, so 6 for sure. I'll cross it out since I'm using it. Any other single digit values? No. Let's go for the ones. I see 19, 12, and 15. So we're going to put them in order. 12 is the smallest, so we'll put 2 here for 12. 15 is the next smallest. I'll put a 5 here for 15. And then 19 would be the largest value. And then we're ready for the 20s. So I see 24, 23, 21. I'll put them in order. 1 will go first, 21, then 23, and then 24. There we go. And that's it. That is our stem and leaf plot. And if I was told to create a stem and leaf, that'd be all I would do. I'd organize the numbers, make my key, and I'm good to go. But if I needed to do more, like maybe I need to find that mean, median, and mode, that would be pretty easy for me to do. I think I'm going to do that right now. Let's do mean, median, mode, and let's put range on there too. I think all 4 of those is good to do. All right, so mean first. Mean is where you're going to add them all up and divide. And I see that there are 1, 2, 3, 4, 5, 6, 7 data points. So we are going to be dividing by 7. We need to add up all of these values. So I'm going to probably just grab my calculator and do that real fast. So what do we have? We had 24 plus 19 plus 23 plus 12 plus 6 plus 21 plus 15, which is a total of 120. So to get our average, we're going to do 120 divided by 7, which again is a decimal. So wiggly equal sign, it is about equal to, I'd say 17.1 on average. 17.1. How about we do the rest of this too? Let's do our median and our mode and our range. Median means middle. These numbers up here are not in order, so whatever you do, do not go to the middle of these numbers and pick that as your median. That would be a big mistake. But these numbers are in order, so if I had to think kind of backwards here, 6 is the smallest value, 24 is the largest. Okay, move up a notch, 12 and 23, 15 and 21, and then look, it looks like 19 is the middle number. So our median middle number is 19. And then mode means what number do we see the most of? And actually, I don't see any mode. Do you see any repeated numbers? They all look completely different. So I'm going to say in this case, there are none. And then the range is just small to large. What's the difference? I think the largest number we ended up having in our stem and leaf was 24. And the smallest number was 6, that single 6. So 24 take away 6 is a range of 18. So our range is a difference of 18. There's our mean, median, mode, and range. Okay, so let's try something else here. I hope this is making sense as you're watching the video. Here's what I would like you to do. I'm going to give you a new stem and leaf plot. Looks like this. It's already made, already done. What I would like you to do is I would like you to pause the video and find the mean, median, mode, and range on your own. In fact, I'll write it over here. We want to know what's the mean, what's the median, what's the mode, and what's the range. So right now I'm really encouraging you, pause the video, try all of that on your own, and see if you've kind of got the hang of how to do this. Okay, so I'm hoping now you're unpausing the video and you're ready to check your answers. And we're going to go through each and every one of these to see if you did it correct. So starting with the top, starting with mean, I see there are 1, 2, 3, 4, 5, 6, 7, 8, 9 values. So we're going to be dividing by 9. Ooh, I also see that there wasn't a key included in this problem. And that's kind of a big no-no on my part. So I better include a key, or else how are you actually supposed to read these numbers? So in this case, 2 and 4, I'll use that as my key, represents the number 24. But you know, this would have really thrown things off. What if I told you my key for 2 and 4 represented 2400? That would have changed all of this data. That means this would have been 1200, 1500, 3300. I mean, you could do that with your stem and leaf. So that's why I'm saying, like, that was a big no-no for me not to include the key, because that would have really changed our answers. But let's go with 2, 4 means 24. Okay, so going back to what we need to do here, there are 9 data points. We're going to divide by 9. We need to add up all of these values. So I'm going to quickly add up 12, 15, 24, 26. Let's see, 12 plus 15 plus 24 plus 26 plus, this would be 31 plus 33 plus another 33 plus a 38 plus this last value, which is 42, adds up to a grand total of 254. So 254 divided by 9 gives us an average of 28.2 repeated. So our average value is 28.2 repeated. Our median number will be our middle number. So going from high to low, kind of working our way in. Lowest number is 12, highest is 42. Then we have 15 and 38. 24, 33, 26, 33, boom, there it is. Middle number is 31. So our median value is 31. Mode means most. I think the most number we see is this one right here, 33 repeated twice. So our mode is 33 this time. And our range is high to low. So highest number was 42, lowest number was 12. If you take 42, take away 12, that's going to be a range of 30. So equals 30. So median 31, mode of 33, range of 30, and then our mean up here was 28.2 repeated. And there's all of our values. So that's the basics of a stem and leaf plot. It's just a way to organize numbers. I think it's really important to note the value of this key, because as you get into the practice problems, you're going to notice that some of the practice problems, the numbers don't represent 24. They are things like 2,400 or 24,000, and that changes everything over here because you've got to make sure you reflect those numbers in your measures of center. So just be really careful about that. We're going to continue to post more videos, but practice this on your own. See if you get the hang of this. That is stem and leaf. Thanks, guys.